Welcome back to Boring Astronomy. In our last episode, we delved into the profound, yet often overlooked, significance of Earth's atmosphere, our planet's invisible shield. We explored how this mundane blanket of air silently provides us with breathable oxygen, regulates our temperature, maintains crucial pressure, and relentlessly protects us from meteors and harmful radiation, making life on our planet possible. Tonight, we turn our gaze to the ultimate source of almost all the energy that drives these atmospheric processes and sustains life on Earth, the sun. It's so omnipresent, so glaringly obvious in our sky, that we barely give it a second thought beyond whether it's a good day for a picnic. But this isn't just a big, bright light bulb. It's a silent, incomprehensibly powerful nuclear furnace, quietly, consistently fueling our entire solar system without a single dramatic flicker. Its boring, unwavering output is the greatest, most vital show in the cosmos. So, dim the lights, perhaps turn on a fan for that soft hum, and let's ease into tonight's journey together. You know the sun. You feel its warmth on your skin. You squint at its brightness in the sky. It's the reason for day and night, the ultimate timekeeper for life on Earth. But what exactly is it? And how does it generate that seemingly endless supply of light and heat that reaches us across 150 million kilometers of empty space? It's not burning in the way a fire burns. There's no oxygen in space to fuel a conventional flame. The sun operates on an entirely different, profoundly boring, yet astonishingly powerful principle: nuclear fusion. Imagine the sun as a colossal, self-sustaining atomic bomb. But instead of exploding violently, it releases energy in a steady, controlled manner. At its core, the temperature is an unimaginable 15 million degrees Celsius, and the pressure is equally immense. Under these extreme conditions, hydrogen atoms are squeezed together with such force that they fuse to form helium atoms. This process, nuclear fusion, releases a tiny bit of mass as pure energy. According to Einstein's famous equation, E equals mc2, it's a slow, constant conversion, happening billions of times every second for billions of years. This isn't a quick burst. It's a relentless, boringly efficient energy factory that has been running for approximately 4.6 billion years and will continue for billions more. Think about the sheer scale of this energy. Every second, the sun converts about 600 million tons of hydrogen into 596 million tons of helium. The missing 4 million tons of mass are converted into energy, pure light and heat. That's enough energy to power roughly 100 billion watt light bulbs, and only a tiny fraction of that energy even reaches Earth. Yet, it's enough to warm our planet, drive our weather systems, and power almost every living thing. It's an almost incomprehensible output, delivered with the boring consistency of a ticking clock. Consider a sunny day, the energy hitting your face, warming the ground, making plants grow. This energy started its journey deep within the sun's core. It wasn't an instant trip. Once created, a photon of light can take tens of thousands, even hundreds of thousands of years to work its way out from the dense solar interior to the surface. It bounces around like a pinball, absorbed and re-emitted countless times. Once it finally escapes the sun's surface, it races across space at the speed of light, reaching Earth in a mere 8.5 minutes. So, the sunlight warming your skin right now actually began its journey inside the sun long, long ago. It's a cosmic message from the deep past, delivered with perfect punctuality. This continuous outpouring of energy is what makes life on Earth possible. Photosynthesis, the process by which plants convert sunlight into energy, forms the base of almost every food chain on our planet. Every leaf that grows, every fruit that ripens, every breath of oxygen we take, it all starts with the sun's quiet, constant output. It's the boring, reliable engine of all biological processes. It's the ultimate sustainer of life, working without a single complaint or dramatic flourish. Even our weather, which we touched upon in the last episode, is fundamentally driven by solar energy. The sun's uneven heating of Earth's surface creates temperature differences, which in turn drive winds and ocean currents. It evaporates water from oceans, forming clouds that eventually bring rain, completing the water cycle. Every gust of wind, every drop of rain, every snowflake that falls is a direct consequence of the sun's consistent energy output. It's the ultimate climate control system, maintaining a delicate balance that allows our atmosphere to function as a protective shield. And what about the sun's boringly predictable cycles? The sunspot cycle, for instance. Every 11 years or so, the number of sunspots, cooler, darker regions on the sun's surface that are areas of intense magnetic activity, rises and falls. This cycle influences solar flares and coronal mass ejections, which can sometimes impact Earth's magnetic field, leading to auroras and, rarely, disruptions to technology. But even these events are part of a predictable rhythm, a natural variation in our star's otherwise unwavering output. The sun doesn't randomly decide to get more active, follows an intrinsic, well-understood cycle, a testament to its internal mechanics. Think of the sun's long-term stability. For billions of years, it has maintained a remarkably consistent energy output, providing the stable conditions necessary for life to evolve, flourish on Earth. This isn't a star that flares erratically or dims unpredictably. Its consistency is its greatest strength, its most profound quality. It's the ultimate example of something so reliable, so constant, that its existence becomes mundane. Yet, its unwavering presence is the very foundation of our existence. Without this boring constancy, life would have never had the chance to take hold, let alone evolve into complex forms. So, the next time you feel the warmth of the sun on your face, or see the vibrant colors of a plant, or simply observe the cycle of day and night, pause for a moment, appreciate this colossal, quiet power source, silently fusing atoms billions of miles away, sending forth a steady stream of energy that ultimately powers every aspect of our world. It's boring in its reliability, yes, profoundly beautiful in its consistent generosity and its role as the ultimate life giver. Next time on Boring Astronomy, we'll expand our view even further and embark on a tour of our cosmic island home, the Milky Way galaxy. We'll explore its vastness, its quiet grandeur, and the billions of stars and systems that make up our galactic neighborhood.